Hi everyone, in this video I want to find the domain of the function g of x is equal to 1 over 1 minus tan x. So for this one, we need to remember that basically the domain of a function is all the x values for which the function is defined. And most of the times when we want to find the domain of a function, we find the x values for which the function is undefined. And then at the end, we say the domain of the function is usually the set of real numbers, and then we exclude those values that make the function undefined. So now here we have this function, and we need to look at for which values of x the function is undefined. Now here there are two cases that we should basically consider. So maybe the more obvious one is the case that the denominator is 0. So we don't want that to happen. So that means we need to find the x values that make the denominator 0 so that we can exclude them from the set of real numbers. So that's the first case. But there is a less obvious case, and that is about the tan function itself. Because remember that tan is a function that is not defined for all the x values. There are some values of x for which the tan function is undefined. So that's the second case. Basically, there are two cases that we need to consider in this question. And then we exclude all of those basically x values that we get from both cases. We should exclude all of them from the set of real numbers. Now let's start with the maybe more obvious case, which is when the denominator is 0. So we can start like this. Case 1, when the denominator is 0. So denominator is 0 when 1 minus tan x is equal to 0. We can rearrange this equation, which is a trigonometric equation. And so if we basically find the tan inverse of both sides, so we get pi over 4. But there is something that we should be aware of, because we need to add n pi here as well as pi over 4. And there is an n is just an integer. So the reason for that is because tan is obviously a periodic function, and basically the period of tan, a period is pi. So that means that the value of the function repeats every pi. So we just basically write down n pi, which makes that general. So yeah, that's why we need to include n pi at the end. So I'm just going to write that here, just to be aware of. Note that tan x plus pi is equal to tan x. So this just means that the value of the tan repeats every pi because it's just periodic. So now these are the x values for which in the first case the function is going to be undefined, and we need to exclude this. But as I said, there is a second case that we need to consider. So in case 2, the case 2 is about the values that make tan function undefined, because again tan is not defined for all the x values. So that's another issue here that we have with tan. And basically this is just something that we need to remember, because the tangent function is undefined at x is equal to pi over 2 plus n pi, where n is again an integer. So this is just something that we need to remember, that the tan function or tangent is undefined for these x values. And in case you're curious, let me just mention that very briefly why this is the case. Because we know that tangent tan x is equal to sine x over cos x. And then obviously there can be some values that make the denominator 0, right? And that can cause some problems. So that's why the tangent function is undefined for some values, because those are the values that make the denominator 0, and we don't want that. So it's just something that to be aware of. So whenever you have tangent in domain questions, always remember that in addition to looking at the domain itself and finding where the domain is undefined, always always consider the fact that the tangent is also a function that at some x values is undefined, as well as the main function you have. So yeah, this is another basically set of values that now we have for which the function is undefined, and therefore domain of g of x is basically all the x values that are in the set of real numbers, except, now we write both of our findings. So except the values that satisfy pi over 5 plus m pi, also, and the values that satisfy pi over 2 plus n pi, given that n belongs to the set of integers. So yeah, that's basically the domain of this function. So thank you for watching this video. Make sure to like and subscribe for the future videos. Good luck.